So yeah, we're going to look at some functions questions, ones you can solve with your GDC. So this is a very long exam question, which I found way back when from 2011. And they often come in these very, very similar to this. So you get a part where you have to sketch the graph. So you can use GDC to do that. You have to find coordinates where they meet the x-axis. So the 0 points, which is the same as when you solve to find x as well. Equation of lines of symmetry, very common. Minimum points or maximum points. You have to be able to work out the range or the domain sometimes. And then what they often do is they add to the starting function, they add another one. And then you have to be able to work with both of those graphs and solve equations generally. I'm also going to look at how to plot a modulus function. We're going to do a little bit of another question after we've done this one. We won't do all of it. Right, okay, so first of all, we are plotting this, or sketching, using your GDC. So x power 4 minus x squared. So let's go from the start. So you go into here, the graph, or click on B here. Recall that to enter quickly, you can click on tab. And then I'm just going to go X. And remember, you got this little power thing here, that little pointy thing is your sort of power button. And then minus, I'm subtracting x squared. So x, and I can use the squared now if I want. And then just press enter. Right, then what you'd do is you would look back at, you would look back at the domain you've been given. So it's between -1 and 1.5. They restricted the domain. And also they want you to draw it between -1.5 and 3. So it makes sense to plop in those coordinates. So let's do that. Coordinates, what am I talking about? Change the scale to match that, I think is what I mean. So, sorry, I looked at it before. I didn't realize I'd already done this. Okay, there you go. Wow, so organized. So just a reminder then to go into how to change it, because if you do this ordinarily, it won't automatically feel that you need that particular domain. So just remember that you can go into Windows settings here and alter your domain and range to make it fit whatever you need. So this is the graph then that we're looking at. Now it's going to be difficult for me, easy for you to sketch than it is for me. But I'm looking at basically a couple of key points here, 3 key points really. 1, 2, 3, where it intersects the x-axis. Right, so I'm going to try and draw it as carefully as I can. I've got an idea of the general shape. Remember, this is only just a sketch. So there was a point about there, and it's not asked us to put the, it was a bit like that, wasn't it? That's the, yuck. That's the general sort of, oh my goodness. Honestly, it's so hard to do this on the screen. I mean, that'll do. Right. And then it just sort of went up like this. I'm probably going to rub a little bit out here for the following reason. You don't really want to go beyond that point because it did restrict this domain. So I'm just kind of putting a little line in there, and I'd rub that out because it did want the domain between those points. So I've gone a little bit too far. And now I've lost the symmetry of my beautiful curve. So I'm just going to add on. I would want them to be equal length because it is symmetrical. Okay. Right, so that's the rough sort of shape. So that should ensure we get 2 marks for that. Right, you've got, clearly intersecting at 2 points, or 3 points, sorry, and you've got the shape of the graph, so it should be fine. Right, next, write down the coordinates of the points where the graph meets the axis. There are 3, we've kind of highlighted them there. So we just go to here, go back to our function, analyze graph. So we're finding zeros. So we're finding the x-intercept. So you go left-hand side, right-hand side, bosh. You go in again. And left-hand side of the point you want to the right-hand side, bosh. And last one. And this is why this is only, I think, 1 mark or something, because it's so simplistic. Right, so there you have your 3 sets of coordinates. I'm going to struggle to put them in. Now, you do need to know here there's 4 significant figures. So you're going to be okay because these are exact amounts. You'll be fine writing -1 and so 0, 0, 0, and 1, 0, because you're not actually rounding those. They're exact values. Right, but anything you do have to round, you will need to make sure you round to 4 significant figures. Sorry, just taking a little sip of coffee there. Right, then once the line of symmetry, well, we have been looking at an equation for that. You really shouldn't need it because it's symmetrical. So you should spot that straight down the middle there. That is the line of symmetry. So what is the equation? I'm drawing that very nicely. Oh my goodness. So yeah, pretty much like that. Right, and so what some of you were struggling with is not, you weren't writing down the equation, you're just writing down like 0. But it's the equation of the line. It's x equals 0. X is equal to 0 at every point down that line. Hence, it is the equation x equals 0. So please don't forget to write the clue is it's an equation. An equation must include an equals sign. Right. Find the coordinates of the minimum point. So some of these will be rounded to 4 significant figures. Now you can do this automatically if you want. So if you go into menu and you go into window zoom and you go into window settings, what am I doing? No, you don't. You go into menu, you go into settings. Okay, now this, if you change this, that would be to 4, fix 4 is 4 decimal places. If you want 4 significant figures, you go to float 4. So if you want more accuracy, you can change this. You might want, I don't know, 6 significant figures for much more accuracy. I'm going to change it then to that. And there we go. So now it's there. My answer from before is beautifully written there. Look at that. Right. So we know their exact values. So that's well done, me. Okay. So let's go in then and find these maximums or minimums in this case. So you go into analyze graph minimum. You go to the left-hand side of the minimum you're looking at. You go to the right-hand side. And then you do the same thing again. Analyze graph. You go to the left-hand side. You go to the right-hand side. And look at how perfectly it has done that for us. So let's just see how good my memory is. Not very. Gone. No, it hasn't. Has it? No. Oh my God. Amazing. Right. Okay. So I do believe I have remembered that correctly, but I will double check. But please note, it has rounded those things to 4 significant figures automatically. So you don't even have to think about that. GDC just does everything for you. It's ridiculous. Right, anyway. Also, just recall the turning points we've looked at to recognize them. A minimum would be shaped like a smiley face, and a maximum is shaped like an unhappy face. Right, now it wants the range when the domain is all real numbers. So they've actually changed the domain here, because in the initial question it was between minus 1.5 and 1.5. Now it's saying for all real values of x. So they've extended the domain for all values of x, which means it's not going to affect the bottom here, the smallest value of y, because we've got that minimum there, but it will affect this. It's not going to suddenly stop here. That's going to go on forever and ever and ever and ever. So it has a starting point here, which we can work out because we know the y value there for the minimum was 0.25 minus 0.25. I didn't copy that down right, did I? My bad. I'd have lost a mark. So minus 0.25 and minus 0.25. There we go, amended. Right, and so that's the starting point. That's the lowest value of y this particular function will get down to. But the values of x go on the values of y will go on forever from that. It's going to continue going on forever and ever and ever and ever upwards. So that means it starts at where y is equal to or greater than 0.25. So you can write, and we'll probably write f of x rather than y for our domain, our range, sorry. So it starts at minus 0.25 and goes on and on and on and on and on and on upwards for y. That is our range. Right. Let's have a look at the mark scheme now. So just to check some of these things. And there we go. Okay, so all looking good. One thing I'd like to point out, it's asked us to round to 4 significant figures. At least 2 significant figures, but if you constantly making the same mistake, it will only penalize you once. However, it must be bare minimum 2 significant figures. So if you were rounding to less accuracy than that, you would lose the marks. So please be, careful. Follow the instructions very carefully. Right. Anyway, there's more. So on the axis, we got to sketch another function. Nasty looking one this is. So 2 to the power of x minus 1.6. So we're going to plonk that on the same graph. Let's see if I can remember that. So I've got, okay, I'm going in doing it this way rather than clicking tab by the look of it. Fine. So 2, go to the power of, there you go, x. And I think it was minus 1.6, but I will go back and check. That looks about right, I think. Okay, so that is, yes, and that was correct. Yay. So now it says we've got to solve that equation. So where this is equal to 0. So in other words, where y is equal, when we're solving an equation, it's where you look at the x-intercepts, where y equals 0. So you're looking at the zeros. So remember, this is why, using graphing functions and solving equations that way is actually the best way to do it. Right, well, there's only one. So there's only one x-intercept. So here we go. Analyze graph, 0. Didn't like that for some reason. So analyze graph and 0. And I'll go in. Oh, it doesn't know which graph I want to look at. So I have picked the red one. And I've got on either side of it. And there we go. And again, it's rounded exactly to 4 significant figures. So 0.6781. Now remember, you're solving a equation. So you don't, some of you get into this habit of just writing down the coordinates. Not asking you for that. You're solving the equation. You only want the value. I'm going to have to take a sip of coffee, sorry. You're only finding the values of x. So please don't continue to make that mistake. Read the question carefully. Right. Now it's combining, and this is an absolute classic, combining both those equations together. So it wants to know when the first function is equal to the second function. Well, that, in other words, you're looking at where they intersect. That's the solution of both of them. So if we go back to our graph the two functions intersect twice. So you go to analyze graph, you go to intersection. Again, left-hand side, right-hand side, grab hold of it. Gosh, it's getting busy, isn't it? Analyze graph and intersection again. Left-hand side of the intersection, right-hand side of the intersection. So where those graphs meet, where they're equal, that will solve that equation. It's literally asking you that. Look, where that function is equal to that function. Well, where's that? Where they intersect. So that is too much for me to copy down, I think. 0.4988, I'll try. Okay. And remember, again, you're solving it. So you're not finding, you're not finding the value, the corresponding value of y. We're solving it to find the value of x. I have forgotten that. Whoops. 1.221. And again, whoops. Again, it's done the 4 significant figures for you. Float 4 is your friend. So we're looking at when the f of x is less than g of x. So f of x was the blue one. So it's here. So you can see where it's less than is where it's under the red curve. Again, memory's so bad, I'm having to check I've got that right way around. So yeah, when f of x is less than g of x, it's here. So you can see this point of intersection I'm looking at. This is where the blue curve is, it's under, it's less than. The y values are less than the y values of the g of x curve, which is the red one. It's very visual. You can see it's underneath it. So starting point is here, bosh, and second point is here. So it's in between the intersection points we just found. So it's going to be in between these points. So 0.4988 and there. Now I haven't, it's not equal to, because it wants it when it's less than that. So it doesn't want the point where it's going to, those graphs are actually equal to each other. So you would not include an equal sign there. So we look again. See very visually from this point here, 0.4998, and all the way up to where it's 1.2, where x is 1.221. The blue graph is less than is under the red graph. So it's where f of x is less than g of x. Very visual.